Dear students, welcome to eShikshana program. In the last few classes, we discussed single step numerical methods, namely Taylor series method, modified method. In today's class, let me discuss another single step method known as Runge-Kutta method of fourth order. Runge-Kutta method of fourth order is widely used method in solving different ordinary differential equations. The Runge-Kutta method fourth order is also by default called Runge-Kutta method. So basically, we try to solve differential equation of the form dy by dx is equal to f of x comma y. That is the first order ordinary differential equation with given initial condition y is y naught at x is equal to x naught. The Runge-Kutta method of solving 1 is given by yn plus 1, that is the value of y at x is equal to xn plus 1 is equal to yn plus 1 by 6 into k1 plus 2k2 plus 2k3 plus k4, where k1 is h into f of xn comma yn, k2 h into f of xn plus h by 2 comma yn plus k1 by 2, k3 h into f of xn plus h by 2 comma yn plus k2 by 2, k4 is h into f of xn plus h comma yn plus k3. Now let us employ this algorithm to calculate numerical values of y at a given specified equidistant values of the independent variable x. Let me take one example. Example, apply Runge-Kutta method, apply Runge-Kutta method. By default, Runge-Kutta method in your course means Runge-Kutta method of fourth order, what I have described here. Method to find an approximate value, approximate value of y, approximate value of y when x is equal to 0.2, when x is equal to 0.2, given that dy by dx is equal to x plus y. dy by dx is equal to x plus y, and y is equal to 1 where x is equal to so we need to find the value of y at x is equal to 0.2. So first, let me write down what is given in the problem. That is very important. First we shall write down what is given in the problem. So in the solution part, let us write down first what is given. There is f of x comma y. F of x comma y is equal to x plus 1. Given f of x comma y is x plus y. and x naught, this is your x naught, initial condition, y is 1 when x is equal to 0. So x naught is given to be 0, corresponding y naught is given to be 1. Next value of x, what you see in the problem, the immediate value greater than 0 is the value of x. There is only one value of x. So I can take this as x1 is equal to 0.2. If step length is not given, suppose step length is given at 0.1 with step length 0.1, then 0.1 should be added to 0. That should be called as x1. Then 0.1 should be added to 0.1 till you get 0.2. Keep on adding 0.1. So and list the values of x1, x2, x3, etc. Okay. So I have to calculate y1, that is the value of y at x is equal to 0.2 using Runge-Kutta method. That means Runge-Kutta method of fourth order. In general, Runge-Kutta method is in your course. It is a Runge-Kutta method of fourth order only. So now let me list the data. I don't want the problem. So given f of x1 is x plus y, x naught is 0, y naught is 1, then x1 is 0.2, the corresponding y1 we have to calculate. And you can easily see h is 0.2 minus 0. x1 minus x naught is your h. x1 minus x naught or x2 minus x1 is your h. So h is 0.2. h is 0.2. Okay, so now Runge-Kutta fourth order formula is given by Runge-Kutta method, that is method of fourth order, method of fourth order is given by yn plus 1 is equal to yn plus 1 divided by 6 into k1 plus k2, 2k2, k1 plus 2k2 plus 2k3 plus k4, where k1 is h into f of xn comma yn, k2 is h into f of xn plus h by 2 comma yn plus k1 by 2 plus yn plus k1 divided by 2. Then k3 h into f of xn plus h by 2 comma yn plus k2 divided by 2. Then k4 is equal to h into f of xn plus h comma yn plus k3, xn plus h comma yn plus k3. So we shall find these k's and substitute here and find the value of y1. So how do we get y1? By fixing n is equal to 0. So this is true for n is equal to 0, 1, 2, 3, etc. By fixing n is equal to 0 in these equations, I can get k1, k2, k3, k4 with the defined function f of x comma y. I am substitute in equation here yn plus y in this equation we get the value of y at x is equal to x. So let us fix. So let me call this entire set of formula equations as 1. Call this as equation 1. Now to get y1 I have to set n is equal to 0 in 1. Set or put n is equal to 0 in 1. So I get y1 is equal to y0 plus 1 by 6 plus k1 plus 2 k2 plus 2 k3 plus k4. So call this as equation 2. Okay, we shall substitute for n is equal to 0 the values of k1, k2, k3, k4 in 2 and obtain the value of y1. So how do we do this? Very simple. So k1, what is k1 when n is equal to 0? K1 is h into f of x naught comma y. H into f of x naught comma y. So what is h? H is 0.2 into f of x naught is 0, y naught is 0 comma. Okay. So now, what is the definition? F of x comma y is x plus y. F of 0 comma 1 is 0 plus 1. So this is equal to 0.2 into 0 plus 1 is 0.2. You can clearly see this is 0.2. Okay. Then K2 h into f of x naught plus n is 0, x naught plus h by 2, x naught plus h by 2, comma y naught plus k1 by 2, y naught plus k1 by 2. Okay. Now let us substitute for x naught, y naught and k1. So k2 is 0.2 into f of x naught is 0, x naught is 0, 0 plus h by 2, 0.2 divided by 2, comma y naught is 1 plus k1 by 2. So k1 by 2 is 0.2 by 0.2 divided by 2. Okay. So apply the definition now. So this is equal to 0.2 into f of x comma y is x plus y. F of x comma y is this plus this. So 0.2 by 0.2. So 0 plus 0.2 divided by 2 plus 1 plus 0.2 divided by 2. So if we simplify this using calculator, we get K2 is equal to 0.44. So K2 is 0.44. Similarly, K3 is equal to h into f of x naught plus h by 2, comma y naught plus k2 by 2, right? K3 y naught when n is 0, y naught plus k2 by 2 plus k2 divided by 2. Okay. Substitute the values for x naught h and y naught k2. So h is 0.2 into f of x naught is 0, h by 2, 0.2 by 2, 0.2 divided by 2, y naught is 1 plus k2 by 2, k2 is 0.24, 24 divided by 0.24 divided by 2. Okay. So now let us apply the definition. So this is equal to, by definition, this is 0.2 into f of x comma y is x plus y. F of x comma y is this plus this. So 0 plus 0.2 divided by 2 plus 1 plus 0.24 divided by. So if you carefully calculate this using calculator, you get K3 is equal to 0.244. So this is 0.244. Now, one more quantity K4 is left over. So K4, I will work it out here. Okay. K1 is 0.2. K1 K1 is 0.2. K2. Now I don't think I require this. Okay. Let me do it here. Let me do it here. So K4 is equal to h into f of xn plus h, and n is 0, x naught plus h comma y naught plus k3, y naught plus k3. When n is 0, h into f of x naught plus h comma y naught plus k3. Okay. Now let me substitute here. H into f of x naught is 0, h is 0.2, comma y naught is 1, k3 is 0.244. 0.244. So apply the definition. H into h is 0.2, h is 0.2 into f of x comma y is x plus y, x plus y. So 0 plus 0.2 plus 1 plus 0.244. So using calculator, if you calculate, you get the value of K4 0.2888, 0.2888. Now let us substitute these values of K to substitute in what? Substitute the values of K's, the values of K1, K2, K3, K2, K3 and K4 in 2. So again, y1 is equal to y0 is 1 plus 1 divided by 6 into K1 is 0.2 plus 2K2, 2 into 0.24, 2 into 0.24, 0.24 plus 2 into K3, 0.244, 0.244, then plus K4 is 0.288. Plus okay. So calculate using calculator. If you calculate this, you will get 1.2428. If you carefully calculate, you get y1 is equal to 1.248. So that is, therefore, y1 is equal to y at x is equal to x1, at x is equal to 0.4 is equal to 1.2428. So I got the value 1.248. That is the numerical value of y at x is equal to 0.2. So this completes the problem. So let me take another example. Let me take another example. Example 2. The second example, using Runge-Kutta method, using Runge-Kutta method, of fourth order solve dy by dx is equal to y square minus x square divided by y square plus x square. Y of 0 is equal to 1 and x is equal to 0.2 comma 0.2. So here I have to calculate the value of y at x is equal to 0.2 as well as at x is equal to 0.2. So this is a single step. Okay. So now the solution part, it is always good to write what is given in the problem. That is the listing the data. Solution. The solution part. So let us write the data given f of x comma y is equal to y square minus x square divided by y square plus x square. This is given. Then what is your x naught? X naught is 0. What is y naught? Y naught is 1. What is the next value of x? 0.2. This is your x1. x1 is 0.2. So 0.2. So corresponding value of y, that is y1, we have to calculate using Runge-Kutta method of fourth order. Then next value, add 0.2 to 0.2, so you get 0.4. So this is your next value, that is x2 is 0.4. Corresponding value of y, that is y2, you need to calculate. And h you can easily calculate. 0.4 minus 0.2 is 0.2, or x1 minus x0, that is 0.2 minus 0 is 0.2. So h is 0.2. So h is 0.2. Okay. Now let me write the data which I require to complete this problem separately here. So given f of x comma y is equal to y square minus x square divided by y square plus x square. Y square plus x square. Then x naught is 0, y naught is given to be 1. Then x1 is 0.2. So y1 we have to calculate. x2 is 0.4 and corresponding value of y2 we have to calculate. So these are the two blanks I have to fill up using Runge-Kutta method of fourth order. Okay, what is h? H is 0.2. H is 0.2. H is 0.2. Now let me write the formula. Runge-Kutta method, I can simply write it as RK method. RK method. RK method means Runge-Kutta method. In short, let us write RK method to represent Runge-Kutta method. RK method of fourth order is given by y n plus 1 is equal to yn plus 1 divided by 6 k1 plus 2 times k2 plus 2 times k3 plus k4. So where k1 is h into f of xn plus xn comma yn, xn comma yn. K2 h into f of xn plus h divided by 2 comma yn plus k1 divided by 2. K3 is h into f of xn plus h divided by 2 yn plus k2 divided by 2. K4 is h into f of xn plus h comma yn plus k3 yn plus k3. So let me call this as equation. Now I have to find first phi 1. I cannot skip phi 1 and then phi 1. So I have to fix n to get y1. So by replacing n by 0, that is putting n is equal to 0, I get y1. Let me do that. So put n is equal to 0. Put n is equal to 0 in the one set of equations 1. Okay. So I get y1, then y1 is equal to y0 plus 1 divided by 6 into k1 plus 2 k2 plus 2 k3 plus k4. Let me call this as equation number. Okay, let me calculate k's and then substitute into to get y1. Similarly, to get y2, what I have to do? I have to put n is equal to 1 in 1 and then continue the same. Okay, so k1, what is k1? Let me calculate these k's first. k1, h into f1, when n is 0, x0 comma y, x0 comma y. So this is h is 0.2 into f of x0 is 0, y0 is 1, 0 comma 1, 0 comma 1. So by definition, this is 0.2 into, okay, so let me write down here. So k1 is by definition, this is 0.2 into y square minus x square divided by y square plus x square. So this is x, this is y. 1 square minus 0 square divided by 1 square plus 0 square. So 1 square plus minus 0 square divided by y square. Y is 1 now. So 1 square plus 0 square. So this is 0.2. This is 0.2. So you can easily make out K1 is 0.2. Okay. So now K2. H into f of x star plus h divided by 2 comma y naught plus k1 divided by 2. and n is 0, x naught plus h by 2, comma, y naught plus k1 by 2. So this is equal to h into f of x naught is 0 plus h by 2 0.2 divided by 2, comma, y naught is 1, k1 is 0.2, so 0.2 divided by 3. Okay. So if you simplify, so this can be written as h is f of 0.1, comma 1.1, 0.1, comma 1.1. Can you see? If you simplify, you get this one. So by definition, this is h is 0.2. If you simplify this one, you get 0.1, comma, this is 0.1 plus 1, 1.1. So by definition, this is 0.2 into 1.1 whole square, that is y square, minus 0.1 whole square divided by 1.1 whole square plus 0.1 whole square. So if you carefully simplify, you get the answer for K2 0.1967. This is 0.1967. So value of K2 is 0.1967. Now K3 is equal to h into f of x naught plus h by 2, K3, when n is equal to 0, x naught plus h by 2, comma, y naught plus k2 by 2, y naught plus k2 by 2. Now let me substitute. So this is h into f of x naught is 0 plus 0.2 divided by 2, y naught is 1 plus k2 is 0.1967 divided by k2 by 2. Substitute. Y naught is 1, k2 is 1.1967 divided by 2. Okay. So now you simplify this one. So this is h into h is 0.2, f of this is 0.1, and this is 1.0983, 1.0983. You simplify this, divide 0.1967 by 2 and add to 1, you get 1.0983, and by definition this is 0.2 into 1.0983 square minus 0.1 square divided by 1.0983 square plus 0.1 square. 0.1 square. So if you simplify carefully using calculator, you get K3 is equal to 0.1967. 0.1967. 0.1967. Now we have to calculate K4. Okay. So K4, let me calculate here. So K1 is 0.2. So let me make a note here. K1 is 0.2. K2 is 0.1967. Okay. So K4 is H into F of X naught plus H Y naught plus K3 Y naught plus K3. So substitute now. Therefore, X naught is what is H? H is 0.2. H is 0.2. Therefore, X naught is 0 plus H is 0.2. Y naught is 1 plus K3. K3 is 0.1967. 1967. Okay. So this is equal to 0.2. Therefore, 0.2 comma 1.1967. Okay. Now, after the definition, this is 0.2 into 1.1967 square minus 0.2 square divided by 1.1967 square plus 0.2 square. Okay. If you carefully calculate using calculators, you get K4 is equal to 0.189. 0.189 is your K4. Now substitute the values of K1, K2, K3, K4 in 2 to obtain the value of y at x is equal to x square. Substitute the values of substitute the values of K1, K2, K3 and K4 into and K4 in the equation. So what do we get now? So y1 is equal to y naught. Y naught is 1 plus 1 divided by 6 into K1. So K1, we got K1. What is the value of K1? 0.2. So K1 is 0.2 plus 2 into K2. 2 into K2. K2 is 0.1967. So 2 into 0.1967 plus 2 into K3. K3 is 0.1967. Okay. Both are same. 0.1967 plus K4. K4 is 0.189. 0.189. So if you carefully calculate this, you get y1 is equal to 1.195. 1.195. So this is the value of y at x is equal to 0.2. Therefore, y1 is the value of y at x is equal to 0.2 is equal to 1.195. 1.195. So this is 1.195. Okay. So now I need to calculate y2 using the value of x1, y1, previous value, single step method. So now put n is equal to 1 in 1. To find y2, put n is equal to 1 in 1. So I get 1 plus 1 y2. 1 plus 1. So y2 will be in terms of y1. So y2 is equal to y1, etc. Call this as equation number Call this as equation number 3. Okay. Now what is your K1? Now substitute the values, calculate the values K1, K2, K3 and K4. So your K1 for n is equal to 1 will be h of f of x1 comma y1, and if you substitute the values of x and y1, you get 0.2 comma 0.1958. So 0.2 into f of 0.2 comma 1.1959 1959 1959. Close the bracket. Okay. Now apply the definition. Apply the definition here. So K1 is equal to 0.2 into y square minus x square, 1.1959 square minus 0.2 square divided by 1.1959 square plus 0.2 square. Okay. So if you carefully compute this using calculator, you get 0.1891. Now let us calculate K2. K2 is h into f1. Then n is 1. x1 plus h by 2. x1 plus h by 2. y1 yeah, this one y1 plus k1 by 2, k1 divided by, and in this one k2 x1 plus h by 2 comma y1 plus k1 by 2. Okay. Now substitute the values. So k2 is h into f of x1 is 0.2. So 0.2 plus 0.2 divided by 2. 0.2 divided by 2 comma y1 now is 1.1959 plus k2 by 2, sorry, k1 by 2. y1 is 1.1959 plus k1 by 2. k1 is 0.1891 divided by 2. Okay. Okay, if you simplify this, you get h into f of, you simplify 0.2 plus 0.2 by 2, that is 0.1, you get 0.3 comma, and if you simplify using calculator, you get 1.2904, 1.2904. Now use the definition. By using definition, you can write this is 0.2, this is 0.2, so this is 0.2 into 1.2904 whole square minus 0.3 whole square divided by 1.2904 whole square plus 0.3 whole square. Okay, if you carefully calculate using calculator, you get K3 is equal to, this is K2, K2 is equal to 0.1794. 0.1794. Okay, 0.1794. Now let me calculate K3. K3 is h into f of, and n is 1, x1 plus h by 2 plus h by 2, comma y1 plus k2 by 2 plus k2 divided by 2. Now let me substitute here. So this is 0.2 into f of x1. x1 is, so let me write here. So 0.2 into f of x1 is 0.2 plus 0.2 divided by 2. y1 is 1.1959 plus k2 by 2. So k2 is 0.1794 divided by 0.1794 divided by 2. Okay. So now if you simplify, you get 0.2 into f of. If you simplify this, so this you get 0.1 plus 0.2, 0.3, comma 0.3, 1.2856, 1.2856. Now apply the definition. So I no longer require this one. Apply the definition. So K3 is equal to 0.2 into 1.2856 whole square minus 0.3 whole square divided by 1.2856 whole square plus 0.3 whole square. If you carefully simplify, you get K3 is equal to 0.1793, 0.1793. The last K value, K4 is left over. So let me calculate K4 now. So this is h into f of, when n is equal to 1, x1 plus h, comma y1 plus k3. That is your K4. Okay, now substitute. So h into f of x1 is 0.2. Okay, let's see right here. h into f of x1 is 0.2 plus h is also 0.2, comma y1 1.1959 plus k3 is 0.1793, 0.1793. Okay. Now if you simplify, so this is 0.2, 0.2, so 0.2 into f of 0.2 plus 0.2, 0.4, and this is 1.375. If you add this one, you get 1.375. Okay. Now apply the definition. So 0.2 into 1.3752 whole square minus 0.4 whole square divided by 1.3752 whole square plus 0.4 whole square. 0.4 whole square. So if you calculate this using calculator, you get K4 is equal to 0.1687. 0.1687. And let's substitute these values in 3. Substitute values of k's in 3. Substitute the values of, I will simply write k's, that is k1, k2, k3 and k4. K's in 3 in the relation 3. So what do I get? y1 in 3. If you substitute y1 is 1.1959 plus 1 by 6 into k1 is 0.1891 plus 2 times k2 is 0.1794 then plus 2 into k3 is 0.1793 plus k4 is 0.1687. So if you compute this using calculator, you will get 1.3751. 1.3751. If you calculate. So that means the value of y2, that is y at x is equal to 0.4 is 1.3751. So I got the value of y at x is equal to 0.4 as 1.375. Now this completes the problem number 2. So let me consider another problem. Problem number 3. The problem number 3. Apply Runge-Kutta method. Apply Runge-Kutta method. Runge-Kutta method. To find an approximate value, to find an approximate value approximate value of y, approximate value of y for x is equal to 0.2 in steps of steps are 0.1. dy by dx is equal to x plus y square. Given that y is equal to 1, y is equal to 1 when x is 0. Given that y is equal to 1 at when x is equal to 0. Okay. So in steps of point 1. Okay. So h is given to be 0.1. Okay. So let me write the given data first. It is always good to write the given data before we start applying the method. Runge-Kutta method of fourth order. Okay. So given f of x comma y is equal to very simple, x plus y square, x plus y square, x plus y square. Then x naught is given to be when x is equal to 0, initial condition, x naught is 0, corresponding y naught is given to be 1. The next value of x, that is x1, is obtained by adding this 0.1 to 0 and keep adding 0.1 to the previous values of x till you get 0.2. So x1 is 0 plus 0.1, so it is 0.1. So corresponding value I have to calculate. So add 0.1 to 0.1 again, because the values of x are given to be equispaced. x2 is equal to 0.1 plus 0.1, that is 0.2. So we need to calculate using Runge-Kutta method of fourth order y at x is equal to 0.2. Okay. And let me write the data here and then continue applying the method for this problem. So f of x comma y is given to be x plus y square, x plus y square. Very simple expression, definition of f of x comma y. And your x naught is 0, y naught is 1, x1 is 0.1, corresponding value of y1 we have to find. Then x2 is 0.1 plus 0.1, 0.2. So y2 we need to find. And h is given to be 0.1. H is 0.1. H is given to be 0.1. Okay. Now let me write the formula now. Runge-Kutta method of fourth order. Runge-Kutta or RK method. We shall write in short. Runge-Kutta method, that is RK method of fourth order is given by yn plus 1 is equal to yn plus 1 by 6 into k1 plus 2 k2 plus 2 k3 plus k4. k1 plus 2k2 plus 2k3 plus k4, where k1 is equal to h into f of xn comma yn, k2 h into f of xn plus h by 2 comma yn plus k1 yn plus k1 divided by 2 yn plus k1 by 2. Then k3 h into f of xn plus h by 2 yn plus k2 by 2 k2 divided by 2 and k4 is h into f of xn plus h comma yn plus k3. So I need to calculate two values of y. First, value of y at x equal to x1, value of y at x equal to x2, that is I have to calculate y1 and y2. I get y1 by fixing n is equal to 0 in this equation. So let me call this as equation 1, complete here, equation 1. Equation 1. Okay. Put n is equal to 0, I get y1. I get y1 when I fix n is equal to 0 here. So put y is equal to, put n is equal to 0 in 1. Put n is equal to 0 in 1. So I get y1 is equal to y0 plus 1 by 6 into k1 plus 2 k2 plus 2 k3 plus k4. Right? Let me call this as equation number 2. Equation number 2. So I need to calculate now these k's and substitute in 2 to get y1. Okay. So k1 is h into f of, when it is 0, x0 comma y0, x0 comma y0. What is x0? 0 comma 1. So this is 0.2 into f of 0 comma 1. But x0 is 0, y0 is 1. So you get f of 0 comma 1. So apply the definition now. Apply the definition. So this is equal to 0.2 into x plus y square into 0 plus 1 square, right? X comma y, 0 plus y square, 1 square. So this is 0.2. So k1 value is 0.2. H is 0.1, sorry, H is 0.1. H is 0.1. So 0.1. So I get 0.1. H is 0.1 in this problem. The previous problem, H was 0.1. So H is 0.1. So 0.1 into 0 x plus y square, 0 plus 1 square is equal to 0.1. This is 1 into 0.1 is 0.1. Now K2 is h into f of x naught plus h by 2 comma y naught plus k1 divided by k2 when n is 0 h into f of x naught plus h by 2 plus y naught plus k1 by 2. Now let me substitute here. So this is 0.1, h is 0.1 into f of x naught is 0, h by 2, 0.1 divided by 2, y naught is 1 plus k1 is again 0.1 divided by 2. Okay. K1 value is 0.1 divided by 2. Okay. So if you simplify, you can write this as 0.1 into f of 0.1 by 2, 0.05, 0.05, comma 1 plus 0.1 by 2, that is 1.05. 1.05. So by definition, This is 0.1 into 0.05 plus 1.05 square. X plus y square. X comma y. 0.05 plus 1.05 whole square. So if you carefully calculate this, you get 0.1152. Okay. This is your K2. Next K3. K3 is h into f of x naught K3. Put x is equal to n is equal to 0. X naught plus h by 2 comma y naught plus K2 y naught plus K2 divided by 2. Now substitute the values now. So this is h into f of x naught is 0, h by 2 0.1 divided by 2 plus y naught is 1, K2 is 0.1152 divided by. You simplify this, so this is 0.1, h is 0.1 into f of 0.05 comma for K3, you get 1.0576. 1.0576. You simplify this, you get 1.0576. Now apply the definition. If you apply the definition, so this is 0.1 into x 0.05 plus 1.0576 square. So if you calculate, you get the value of K3 0.1168. 0.1168. Now let me calculate K4. Similarly, K4 is equal to h into f of x naught plus h, x naught plus h, comma y naught plus k, y naught plus k. So this is 0.1. Okay, so let me write here 0.1 into f of x naught is 0 plus h 0.1, y naught is 1, K3 0.1168. 0.1168. So K4 is equal to 0.1 into f of 0.1 comma 1.1168. 1.1168. 1.1168. Okay. Apply the definition. So K4 is 0.1 into 0.1 into 0.1 plus 1.1168 whole square. 1.1168 whole square. So if you carefully calculate, you get K4 is equal to 1.1347. 0.1347. 0.1347. Now let us substitute all these values into to obtain y1. Okay. So k2, this is the value of k2. Now substitute the values of k's. Substitute the values of k's in 2. Substitute the values of k's into. Okay. So I get y1 is equal to y0. Y0 is 1 plus 1 divided by 6. K1. K1 is 0.1. K1 is 0.1. 2 into K2. 0.11. 0.2 plus 2 into K3. K3 is 0.1168. 0.1168 plus K4. K4 is 0.1347. 0.1347. 0.1347. 1347. Okay. Close. So if you get the calculator, using calculator, you get y1. You get y1. Y1 1.1164. 1.1164. Okay. So I got the value of y1. That is y1 is equal to value of y at x is equal to 0.1 is 1.1164. 1.1164. So this is 1.1164 up to 4 decimal places. The next I have to calculate value of y at x is equal to 0.2. So I have to fix n is equal to 1 in 1. So put n is equal to 1. Put n is equal to 1 in 1. So you get y2 is equal to y1 plus 1 by 6 times k1 plus 2k2 plus 2k3 plus k4. Call this as equation 3. Call this as equation 3. Okay. Now let me calculate k1. When n is 1, k1 is x1 comma y1. x1 comma y1. So k1 is h is 0.1. x1 is 0.1. y1 is 1.1164. 1.1164. Okay. Now apply the definition. Apply the definition. Apply the definition. So K1 is 0.1 into x plus y square. 0.1 plus 1.1164 square. So if you calculate using calculator, you get y over K1 is equal to 0.1346. So this is 0.1346. 0.1346. Next, K2. K2 is h in f of when n is equal to 1. x1 plus h by 2. f of x1 plus h by 2. x1 plus h by 2. Comma y1 plus k1 by 2 plus k1 divided by 2. Okay. Now let me substitute the values. So K2 is equal to H is 0.1, H is 0.1, F of x1 is also 0.1 plus H by 2, 0.1 divided by 2. Y1 is 1.1164 plus K1 by 2. K1 is 0.1346 divided by 2. K1 by 2, 0.1346 divided by 2. So if you simplify this, you get 0.1 into f of for K2, we get okay 0.15, 0.15 comma, if you compute this, it will reduce to 1.1837. So apply the definition. If you apply the definition for this f of 0.15 comma 1.1837, you get x plus y square. So 0.15 plus 1.1837 whole square. So if you compute this carefully, you get 0.155. 0.155. This is the value of K. Now similarly, K3, H into F1, when it is 1, x1 plus h by 2, x1 plus h by 2 plus comma y1 plus k2 by 2. So k2 is 0.1551 divided by 0.1551 divided by 2. Okay. That's okay. This is k2 by 2. We substitute options k2 by 2. Now substitute the values. So h is 0.1 into f of x1 is 0.1, x1 is 0.1 plus h by 2, 0.1 divided by 2, y1 1.1164 plus 0.1551 divided by. So now, if you simplify, this is 0.1 into f of, this is 0.15 comma. If you compute this, you get you get 1.1939, 1.1939. Okay, apply the definition now. If you apply the definition, this is 0.1 into f of, so 0.1 into x plus y square, that is 0.15 plus 1.1939 whole square. 1.1939 square. So if you compute carefully using calculator, you get K3 is equal to 0.157, 0.1575. Now last value of K4 is h into f1 when n is equal to 1, x1 plus h, x1 plus h, comma y1 plus k3, y1 plus k3. Okay, this is equal to 0.1 into f of x1 is 0.1 plus 0.1, comma y1 is 1.1164 plus K3 is 0.1575. So this is 0.1575. 7 5 1 5 7 5. Okay. One five seven five. Now K4 is equal to 0.1 is your flux. 0.1 plus 0.1 is 0.2, comma, and if you compute these two, add these two, you get 0.2739. 1.2739. Now after the definition, so this is 0.1 into 0.1 into x 0.2 plus y square 1.27 1.2739 square. So if you compute carefully using calculator, student calculator, K4 is 0.18 double. Okay, now I have completed finding the values of K's. Now substitute the values of K's in 3. Substitute the values of K's, that is K1, K2, K3 and K4 in 3. Substitute the values of K's in the relation 3. So what do you get now? So you get the value of y at x is equal to x2 as y2 is equal to y1. y1 is 1.1164 plus 1 divided by 6 into k1. k1 is 0.1346. 0.1346 plus 2 into k2. k2 is 0.1551, 0.1551 plus 2 into k3. k3 is 0.1575, 0.1575 plus k4. k4 is 0.18 double. Okay. So if you carefully compute using your calculator, you calculate carefully, you get y2. y2 is equal to 1.2734. 1.2734. That means the value of y, that is value of y, that is y2, value of y at x is equal to 0.2, that is your y2 at x is equal to 0.2 is equal to 1.2734. So I got the value of y at x is equal to 1.2734. Now this completes the problem. So I will conclude here this RK method, that is Runge-Kutta method of 4th order. By default, RK method means Runge-Kutta method of 4th order. So we have solved 3 examples. Similar examples you can always do it. So next class I will come up with some other method prescribed in your syllabus for solving first order ordinary differential equation. Thank you.